letter answer in AP homework help, and once almost everyone has done it, we'll go over it. Or actually, if you don't want to be seen, you can private message it to me. Either one. I just need to know that you've done it. And we're doing 38.
Did you say this is one that all three of us missed?
Yep.
Okay, then.
Okay, waiting for 3 more answers. I guess 2. I already know it's Sahil, but so 2 more. Okay, 1 more. All right. Um, so Neil, I have to ask you, were you guessing like completely, or do you have a logic as to why you think it's A?
Uh,
If you were just guessing,
I
like that's
was
fine.
kind of guessing, yeah, because I just saw
Okay.
M1 and then I just assumed it might be the other two combined.
Yep. Okay. So let's look at this problem. It says that they're sliding at a constant velocity. So since we know they're sliding at a constant velocity, what else do we know?
No acceleration.
You're right, no acceleration. And if we know no acceleration, what does that tell us?
The forces cancel out.
Or no net force, right? So all the forces have to cancel out.
Mm-hmm.
So we know that there's a friction force, and we know that they're sliding at a constant velocity. And so it's asking what is the force of M1 on M2, right? So they're all being pushed this way, which means that any force acting on M2 also inherently has to act on M3, right? If you push block M2, it's going to push M3. So since everything's moving at a constant velocity, we need to figure out what force or what resistive force is being produced by M2 and M3 that then has to be counteracted by M1. And that's going to be the frictional force. Can anyone remind me what the equation for frictional force is?
Coefficient times normal.
Yeah, times normal. And in this case, where it's just blocks on a table, what is the normal force?
mg.
Gravity?
Mg, yep. Mass times gravity. And in this case here, because we're talking about 2 blocks, M2 and M3, M is really going to be M3 plus M2. And that is why the correct answer is M2 plus M3 G mu.
Wait,
Wait, could you explain that again? How you got the m equals m3 plus m2?
Right, so I'll back up a bit. Okay, so it's asking what is the force of M1 on M2, right? Whenever we apply a force to M2, inherently we're also going to be applying a force to M3. If you imagine M1's not here and you push M2, you're going to also push M3, right? So you're effectively pushing both masses, and whatever frictional force is associated is going to be the sum of the frictional force from M3 and M2. And we know that it's sliding at a constant velocity. So whatever force is being applied from M1 has to counteract both the frictional force of M2 and the frictional force of M3. Because even though you're just pushing on M2, you're really pushing on both M2 and M3.
okay.
Thank you.
I think I get where the so it's the, wait, the answer was D.
A.
Oh, it's A?
The other thing is, let's say you wanted to look at it just like this. So what would be the frictional force produced by M3? Just M3.
M3G coefficient of friction.
Correct. So M3G mu. This one is going to be M2G mu. And the sum of them is just going to be M3G mu plus M2G mu. And then you can factor out G mu, and then you end up with the same answer
Okay,
of
I
M2
think
plus
I get it.
G mu. So it doesn't matter which way you think about it. If you think about it as, adding the masses, or if you think about adding the forces, they both get you the same answer.
Did we do anything else before I made it here? Like,
No.
okay, good.
Okay. So does anyone have any questions about why this question is the answer that it is?
I understand the equations, but why would you made an arrow like on M1 saying that it's going to be moving to the left along with the force. So, but then why would M3 and M2?
So as the full system, there is this initial force here, right?
Yeah.
Then there is some frictional force M1 that is pulling this way.
Yeah.
The remaining force, so F minus the frictional force of M1, is this arrow here.
Yeah.
Then in this one, you have another force that then pushes M3, and there's this force. So this arrow minus this arrow is this arrow. And then lastly, this one will have no net. It will have a frictional force this way, which is identical to the arrow from M2, making the whole system have a net force of 0.
Okay.
I just didn't draw those because you don't really need to think about them. You can just think about the two forces going this way, and that the sum of these two forces has to be this force here. Does that make sense?
Yes.
Yeah.
Okay. That was the last one that everyone got wrong. However, I want to look at, I guess we'll just start going to the ones that multiple people got, multiple people got wrong. This was a graph question. Oh wait, never mind. It was this one. My bad. 42. Yeah, 42 is the one I'm looking at. Remember that this one was a select 2 answers question. Again, if you're fine putting it in a general chat, put it in AP homework helpers. Otherwise, if you don't want that, you can DM it to me. Except unless you've already taken the test, then don't worry about it. Again, once you think you have the 2 answer choices for 42, if you haven't taken the test, put it in AP homework helpers or message it to me so that I know that you've done it.
Wait, did all of us get this wrong?
No, this was not one that everyone got wrong. This was we've done all the ones that everyone's gotten wrong. This one was one. I'm now going to ones that multiple people got wrong.
AKA 2 out of 3.
Yes, pretty much. Okay. Does anyone know if Rashab is like actually here or not? Because I know he said he has like 5,000 ping. Cool. Can you see the question?
Hey yo, can someone catch me up on what we're doing? I just finished eating. I'm so sorry.
We are answering question 42. Select 2 answers and put them in either AP Homework Help if you're fine with putting it in a regular channel, or you can message it to me or Alan if
Alright.
you don't like that.
Thank you, my dude.
I'll wait a little bit longer since we just got someone. I think we're just missing Ellie, except for Rashab, but again, 5,000 ping, so I'm not gonna wait.
I messaged mine to Alan, but he didn't respond or anything, so I think he's dead.
Well, yeah, I mean, I'm here. It's just when I'm
Oh
recording
yeah,
the
he's
thing, I don't get a
recording.
ping.
Yeah, message to me next time because I forgot he's recording. But yeah, okay.
Yeah,
never mind.
alright.
Okay. So the correct answers were A and C. So C is sort of the easy one of the two. It is that because they have the same kinetic energy. But actually, can anyone remind me what does work?
Change in energy.
Force times a displacement.
Both are correct, but what is relevant here is that work is just a change in energy.
Oh yeah.
And so if they have the same kinetic energy and they stop, well, the final kinetic energy is going to be 0, and their next kinetic energy is the same. So this change in kinetic energy will be the same. So they will have the same amount of work. So that is option. That's why C is correct. And then for A, you have to sort of look at the 2 different equations. So does anyone remember what the equation for momentum is?
MV.
MV.
MV. And then obviously kinetic energy is 1/2 mv squared, right? So imagine hypothetically that the mass is doubled of an object, right? So if the mass is doubled, here, let's say 2m, in order to keep this whole thing constant, we have to have a 1/2 somewhere else. And that's going to have to be a decrease in the velocity, right? And that is really going to be 1/√2. So the velocity will decrease by 1/√2. Okay, I don't have enough time for, or I don't have enough room for that. Okay, every single time. And the reason is 1/√2 squared is 1/2. So when you evaluate this whole equation, and you square the 1/√2, that's 1/2, this is 2, multiply them together, and you still get your original 1/2 mv squared, because kinetic energy is constant. So if you doubled the mass, its velocity would have to decrease by 1/√2. Plugging that into momentum, that gets you that the momentum of this object increases. It does not stay the same, right? Because this is going to be 2, this is going to be 1/√2. So its velocity is not decreasing by the same value. It's not like one increases, one doubles, and one halves. It's a square root relationship. So if mass grows, velocity grows at a slower rate, so therefore the one with the greatest mass will have every time. The one with the greatest mass has the greatest momentum. This one was a hard relationship to identify, so don't feel bad if anyone didn't get that, or I guess didn't get the reasoning why.
Yeah, I was just like, if I get hit with a shopping cart with more stuff in it, it's gonna hurt more.
You know what? I mean, if that got you the answer, no problems there. It's a multiple choice question.
Oh yeah.
So, you could also do process of elimination as long as you found C, you could look at D. God. You could look at D and say, well, this doesn't make sense because they could have different masses and just lower velocity, and that doesn't It would not require the same amount of force. And then similar reasoning for B. They could just have different masses. But if they end up reaching the same kinetic energy, then their mass to velocity relationship is not equal, so they would not have the same momentum. And impulse, by the way, is changed in momentum. If anyone doesn't remember that. Anyway, question. Anyone have questions about this one? Cool. Okay, which one was this? Okay, let's do these graph questions here. These two. As always, put your answer in a chat or message it to me. And remember, it's 2 questions.
Which question are we looking at?
40 and 41.
Could you zoom in like a slight bit? That is so poggers, thank you.
Why am I related to you?
You say this shit at home all the time.
No, I don't.
Hey, we are being recorded here, alright?
Oh, I'm so stuff. I'm so sorry.
I mean, cast is over, so like, it's not like anyone's gonna look at it, but still.
It's the thought that counts.
I hope you all appreciate the graph, by the way, because I made that myself. That took way more time than I care to admit, alright? So, I hope it's appreciated.
Very much.
Again, once you have your 2 answers, put them in AP Homework Help or private message it to me. This is 40 and 41. Okay. That's Neil did it in chat. Let's see, Helen already took it. So waiting on Ellie. Ellie.
You got this, Ellie.
Alright, thanks for that response, Ellie. Appreciated.
You're welcome. Very in depth, you know.
How'd you make this graph?
GIMP, I drew a line, I drew some other lines, I drew like this line and added numbers.
Bruh.
All right, so the correct answer for 40, hold on, let me just peek at the answer key, was B. So, this one's asking about velocity. Can anyone remind me how we get velocity from an acceleration graph?
It's the slope. Right?
From an
Area.
acceleration
Try
graph.
again.
From
Try
an
again.
From an acceleration
Wait.
graph.
Area.
Yes, it is the area
Oh.
under the graph. So one foolproof way to always get this right is look at the units, right? So acceleration is meters per second squared, right? Whenever we get the area, we're multiplying. What unit is the x-axis in?
Meters per second squared.
What unit is the x-axis?
Oh, my bad.
Sec-
Seconds.
Seconds. So we're multiplying by seconds. And so meters per second squared times seconds cancels out the exponent, so we get meters per second. And meters per second is velocity. So it's how you can always get it right. You can do the same thing with slope, right? So if we said we're doing meters per second squared, and we take the slope, whenever we do slope, we divide. So we're dividing by seconds, and that ends up being meters per second cubed, which is not anything that you guys need to worry about that's jerk, but you guys don't learn that, so it doesn't matter. But the point is that you can always get it right by looking at the units and what you're doing. So if you
I
forget,
think I
oh,
want to
velocity,
change my answer for 41. Am I allowed to do that?
go ahead. I mean, it's not like I'm grading this. You missed the actual test.
Okay,
but-
never. Okay, never mind then. I'll just go with it, and I'll hit myself if my Okay, never mind. Yeah.
Cool. All right. So now that we know that the area under the graph is what velocity is, what we can see is during this whole every time during this whole section, velocity is increasing because area is increasing this entire time, right? Up until exactly 4, where velocity area starts decreasing. Remember that any area that is below the graph is considered negative, right? So, over at 4, it would be like, I think, an area of 8. And then slightly after that, it starts decreasing because all of this area is negative. So the point in this graph where it has the most velocity is at 4 seconds. That's the only time, or everywhere before 4 seconds, it's constantly increasing. Now, before I move on to the next question, I want to ask, what will the velocity be after 8 seconds?
Zero.
0. Why is it 0?
Because the two triangles, the positive one, the negative one, are equal. So they're gonna cancel
Correct.
out by the time you reach 8 seconds.
Yep. This one's positive, this one's negative, and they're equal. So by the time we're at 8, the velocity is 0. So the second question to that is the velocity positive the entire time? Or does it ever become negative?
The velocity does become negative.
When would the velocity become
From
negative?
4 seconds to 6 seconds.
No, it's not negative. It's just slowing down from
Oh,
positive
wait,
from
yeah,
wherever
that's right,
the
that's
highest
right,
point was
that's
to
right.
0.
Correct.
yeah.
It goes from 0 at the beginning to some positive number and back down to 0. It's never actually negative. So it's constantly going in the same direction the entire time. It just ends up slowing back down. So it's always going in the same direction, meaning that it's farthest from its starting position after 8 seconds, D.
I'm crying.
It's okay.
Better to cry now than on the test.
So does anyone have any questions as to why this one is the way that it is?
Wait, so I know I keep asking you to like explain it again, but my brain can't process this. Could you please explain it again?
Both or just 41?
No, just 41.
Right. So what we were saying was that velocity is positive the entire time, because if we were to draw a graph of velocity over time, right? You can see it starts off at 0. It increases from the period 0 to 4 seconds, so it looks something like this. And then it's constant at 4 seconds, and then it starts decreasing between the period of 4 to 8 seconds, right? And remember that this value here is always the area under the graph. So this is all positive, and then this is all negative, but it starts like like they add together. So the entire time velocity is positive, meaning it's always traveling in the same direction. If it's always traveling in the same direction, it's always going to be getting farther from its original starting position. So the answer to the question, at what time would the car be farthest from its original starting position, is going to be after 8 seconds, because it's always getting farther from its starting position.
So it's gonna sound like mega dumb, but so the thing is that like when I'm thinking about it with like, oh,
Right, you can keep talking.
okay,
Hey,
so
I'm
when I'm
sorry.
thinking about it, so you know how it goes like up and then like down, so there's like two triangles. So when it has like a point and then like I don't know, basically like for lack of a better term, turns around. Like, so doesn't that mean there's a point in the acceleration where it slows down and speeds up again? Or is my
Um,
brain like not working?
Are you talking about like a change in acceleration, or?
Yeah.
Well, the change in acceleration doesn't mean there's a change in. There's not. It's a
Ooh, that's a hot.
change in the velocity. It doesn't move. It doesn't like change direction
Like
or.
at like 6 seconds. You know, like how
Uh-huh.
there's like a point and then it turns around.
It would be like uh hitting the. It'd be like switching from brakes to gas. If you want to think about it
so
that way.
you're right. So here's the way I look at it. Remember, the slope of a velocity graph is acceleration, right?
Hmm.
So that means if we were to, and this isn't technically a fully correct velocity graph because I'm going to draw it a little bit better in a second. At the very beginning of the velocity graph, the slope would have to be 0. At 2, the slope would have to be 4, and then at 4, the slope would have to be 0 again. So it would look more like that, where it's increasing, and then at 2, it's the highest slope it will be, and then at 4, it's back down to a slope of 0.
Oh, right,
And,
that makes sense.
and
I thought it looked like the upside down V like that one. I was like, whoa, what?
yeah, so this really is the more. I mean, I just kind of drew this one fast, but this is really more correct of what it would look
All
like.
right. All right, that makes more sense. Thank you.
All right, close enough. All right, any other any other questions on 40 or 41? Cool. Okay. At this point, from people who took the test, do you have any questions that you guys want to go over?
I just got here, bro. Sorry about that.
Yeah, it's fine, but you still have the test PDF. So, do you have any multiple choice questions you want to go over?
I'll check. Hold on.
This goes for everyone who took it. Do you have any questions, specific questions you guys want to go over?
Wait, actually, do you guys have? Did you guys send the test anywhere? Like, cause I don't have the original.
It is. I mean, there's the one with answers in practice exam answers, which still has the questions.
Exam answers. Okay, thank you. Yeah, I'll check that.
I realize now by telling you that everyone's just gonna look at that for the answers, but don't do that.
Well,
If they're smart, they won't do that.
I actually was planning on taking the test on like my own time. Should I just like steal that from Alan? Alan, do you have the file?
Yeah.
Okay, donate por favor eventually.
Yeah, I was planning on doing the same thing. Could I like when I take it, most likely next week, just like is it okay if I like
If you're, I'm
send
just
you-
gonna say, if you're taking it next week, don't you have? Isn't that like the week of your guys' test or something
No,
like that?
well, like on Monday
No.
because I have yeah.
no, our test is the week after.
It's the week
Yeah,
after.
there's
Yeah.
it's like the third or
Yeah,
thing.
like in this week. I mean, like I'm not gonna take it right before the
Mhm.
exam. But if I have
Okay.
any questions, can I ask you guys? Like, because
Sure.
I
Yeah.
know we went over them, but like I'm most likely going to have a lot of things wrong. So
Yeah, that's fine. And if you take it on your own, if you want us to grade it, I mean, as long as you give it to us before the end of next week, we'll still grade it because like it's not very hard if it's only a couple people. So feel free.
4, 5.
What'd you say?
4, 5, 7, 8, 9.
Oh, that you're listing questions.
Yeah.
Okay, I was very confused. But yeah,
Okay.
if you want to take it and you want us to grade it, if you want us to grade multiple choice, please use the answer sheet so that I can scan it. And FRQs you should really print, but if you can't print, I guess use a piece of paper, but that's kind of lame. Anyway, you were saying 4, Sahil?
4, 5, 7, 8, 9.
Bro, I was literally about to say 4, 5, Yeah, I was about to say 4, 5, and 8, bro. That's wild.
Bro, I just thought he was counting.
I was confused. That's yeah. All right. Well, here's 4. So everyone can look at it for a second. All right. So whoever didn't take the test, just put an answer. I realize you can see the correct answers, but just put an answer in somewhere so that I know you've read and thought about the question. Excuse me. Who put it in homework help? Neil. So we're waiting on Rishab and Lana.
Wait. Do I have to like answer these?
No. Oh wait, who's talking? Thehan?
Yeah.
No, because I already know your answers, so I'm just asking for the
Alright,
people
dope.
who haven't. Okay, I believe that's everyone. Yes. So yeah, I don't know why you're answering it. Like I already know what you put, but
No, I changed my answer for 4, but I still don't know how to do 5.
all right. So let's look at number 4. So when the arrows are getting shot into the bale of hay, what is going to be the force that opposes that motion or like is gonna stop it? What type of force would that be?
Air
Would it be
resist
friction between
grav-
the hay and the arrow?
Right,
the normal
friction.
force of the hay. What?
It would be friction that we're talking about being shot into a bale of hay. Right? Now here's the thing. You can talk about air resistance and you can talk about gravity. Thing is, both those are going to be very negligible compared to as far as dissipating energy. Well, for one, gravity is going to be extremely negligible because it's being shot horizontally and gravity is down. They are perpendicular. So it is not going to it's going to do almost nothing as far as slowing it down, right? And then air resistance, technically it doesn't say air resistance is negligible. But compared to the force of friction from the bay, that is doing absolutely nothing. So the most prominent force here is the force of friction. And the force of friction is going to be constant because the only thing that force of friction depends on is the normal force. And they're identical arrows, so they're going to have the same mass and everything else. So it doesn't matter that they're shot at different speeds because the normal force exerted by them is going to be the same. So if we have some kinetic energy and we have some friction force, what is the equation that we can relate force and the penetration distance to energy?
Um,
Or just think about energy equations. What is one of them that would be relevant here?
1/2 mv squared.
That's kinetic energy, but you're given that in the problem.
Oh.
And the reason why that's not what I'm looking for here is because I want one that relates it to penetration distance as well.
The spring kind of.
No, it's not spring. It's not spring.
Not
What is
spring.
what are the other energy equations?
Rotational and
Work.
Alright,
Who said work?
I did.
Okay, and what is that equation?
Change in energy over something, I forgot.
Alright, guys, it's force times distance. Or really, it's force parallel to distance, but force times
Force
distance.
sine theta.
Yeah.
Or you can just put the parallel sign and call it a day.
Yeah.
So, and the reason why we don't need to include sine theta is because we're already talking about the component of friction that is parallel to distance. So it doesn't matter. Like we don't need to include the sign because we're only exclusively talking about that force, and that force is going to be constant. So if we then solve for d, we would get d is equal to kinetic energy over the force of friction parallel. And we know this is a constant. So if we double kinetic energy, what happens to the distance?
If you double kinetic energy, it doesn't go twice as far. Wait, no. I said it. So, if you double kinetic energy,
Just look at the equation. If you double kinetic energy, what happens to the distance?
2 times energy equals 2 times distance, right? Because you would
Yeah, it
double
would
the
be twice the distance. That is correct. Because if you put a 2 here, maybe I misunderstood what you said. I thought you said doesn't. I don't know.
No, I said
But-
double.
Okay, so I misheard you said doesn't then. Sorry about that. But you put a 2 here, you have to put a 2 here. Both sides get multiplied by 2. What is this flawed logic going on in AP chat?
So for 5, I just thought like the change of the speed was 6 by c, which is 4, and then the only one of the answer choices that's close to 4 is 5 times 80, which is 400, and I don't know, just the 4 makes sense. So I don't know. I just picked C, and yeah.
That's logic. That's how he gets better scores than everyone.
All right, so the correct way to do this is to look at. So again, what is work? Not force and distance, but in general, what is work? Remind me, we talked about this a little bit ago.
Change in energy. Or
Change in energy. Correct. Yep. And so our initial kinetic energy is going to be 1/2 m v naught, and our final kinetic energy is going to be 1/2 m v, where this is v naught and this is v. What is our change in energy going to be?
Change of energy is force times distance, right?
Okay, if we have a final energy, which we have here, ours is 1/2 mv
Yeah.
is our final, and we have our
Yeah.
initial energy 1/2 mv naught.
Yeah.
These should both say it squared. I'm dumb. How can we from these
Oh,
two values?
you're
How
just
can
gonna
we get
subtract
change
the
in
final
energy?
from the initial.
Exactly. We would just take
initial
1/2. No, it's final minus initial. Always remember that.
Oh.
1/2 mv squared minus 1/2 mv naught squared is going to be equal to change in energy, which is the same as work, right? And you just kind of plug it in. You have the mass and you have the velocities. You subtract them, and that should get you. What do I have here? 80, which is C.
Wait, so just for number 4, the thing was I said that if it had twice the energy, I figured that just meant that it had like twice the velocity since they were the same mass. So then I figured if you
Yeah,
had
that's
twice
what
the
I thought as
velocity,
well.
and then you get like 4 times as much.
Oh,
But then
So-
well,
like
that's
back
right.
twice the energy, then squaring it wouldn't make any sense. So that was
I
dumb.
put
Well,
C
also
as
the other
well for
thing,
the
remember the equation for energy is equal to 1/2 mv squared. So if it has double the energy, it does not have double the velocity. It has
Exactly.
root
That's-
2 times the velocity. So yeah.
Yeah.
But the better way is just to look at work in equal force times distance. Blah 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 blah. Any questions about 4 and 5? Okay. I know no one asked for 2 and 3, but 2 and 3 is a good question, so we're gonna do it anyway. Everyone on the test got this right, I'm pretty sure. But yes, everyone on the test did get both of these right. However, it is still a good question, so I want to go over it anyway. So you guys who haven't taken the test, if you could message me or put in chat the answers, that'd be good. Also, is Alan still in here or no?
Yeah, I'm here. What's up?
No, other Alan.
Oh,
No.
I think.
Damn, that was it.
Okay. Well,
Yeah, I'm about to
so-
lower your score, bro.
Okay. Also, again, as a reminder, any questions we don't go over, we wrote and or took explanations from Albert.io for all of the questions, so you can always open that PDF and either see our trashy half-written 1 a.m. explanations or Albert.io's.
they weren't even our half-written explanations. We pulled them from MIT.
Well, all the ones that Keneal did, he changed them because they were way too confusing. But
Oh.
some of them were just all the ones you did were just copy pasted.
Yep.
Because you cringe.
What do you mean? Because I'm cringe? They were right there. It was easy.
I guess so. Alright, so again, we're looking at questions 2 and 3. Once you have an answer, put it in homework help, AP homework help, or message it to me. Okay. Still waiting on Neil, Rishab. And that's it.
I sent mine in homework help.
Oh, sorry, it didn't notify me for some reason. My bad. Then just Rishab, who may or may not be here. We will wait a second. What, did you get it right?
Are you guys answering a problem right now, or are we working?
Yeah, they're looking at 2 and 3. I am waiting for Rishab, but I don't know if Rishab's even here, so I think I'm just gonna start explaining.
Okay. Can you explain number 4 like really quickly because I missed that after that?
At the end.
Okay.
Okay, so first of all, this graph is okay. I'm gonna need to put on Do Not Disturb because I'm getting notifications from you guys talking about how he guessed the answers. So this diagram is interesting. Can anyone tell me like what this diagram is really telling us?
Shows their position, like at each second, and
Yeah.
then shows their. Yeah, that's it.
So what is object A doing or cart A doing?
It's changing its acceleration at the end, it's deaccelerating.
Yeah, it's decelerating. So it is
Oh.
slowing down. It starts off with a large velocity and it slows down at the end. What is cart B doing?
Constant throughout the whole.
Yep.
So 0 acceleration.
And what is cart C doing?
Increase acceleration and velocity throughout the whole.
Yeah, so it starts off at slow speed and accelerates to a large velocity. So how far do each of these carts travel the same distance?
Yes.
Okay, and how long do each of these carts take to travel that distance?
8 seconds.
8 seconds, right? So we know that velocity is equal to distance over time. And the thing is, for every single one of these carts, the distance is the same and the time is the same. So the correct answer for number 2 is all of the average velocities are equal.
Let's go. I had no idea how to do 3, but I got 2 right. So
You didn't even message it unless you put it in the regular chat.
I forgot to
didn't.
message people, but I did get C for the second one. Okay.
Okay, what'd you get for 3? What'd you get for 3, huh? What'd you get for 3?
Bro, I don't know. It was scary.
All right. So, what did we say about B? What is it doing?
Bro, that man like ain't accelerating.
Constant velocity.
Yeah, it's at a constant velocity. So if it has a constant velocity, which means it's not accelerating, what do we know?
It straight up doesn't have a force on it.
Force is 0.
Exactly. So this has to, now whatever answer we pick, this has to be the least, because we know that these two have non-zero forces on them, because they're accelerating. So B has to be the least. And that leaves us with, actually, it literally leaves us only with B. So that you could get the answer based solely on that. However, if you wanted to take it a step further and figure out why A is equal to C, what you're looking at here is the separation of the dots here is the same like as C, but just in the reverse order. So this is experiencing a force in this direction that is slowing it down, and this is experiencing a force in this direction speeding it up, and they're identical because the separation of their points are the same, just in reverse. So since it's asking for magnitude, direction doesn't matter, and force A is equal to force C.
I got a question. If it doesn't, so can something have an acceleration only if it has a force on it?
Correct. It has to have a
Wait,
net force. A net force has to exist for an acceleration to exist.
Oh, so you can't have an acceleration without a force. That's wild.
I mean, if you're saying this is wild, like this is like basic kinematic, not even kinematics. This is like
No,
fundamentals of
knew that.
physics.
No, I knew that like if there was an acceleration, there was like a force. But I always thought there was gonna be like some random exception somewhere in physics. So I wasn't 100% sure. I just assumed it for the test.
No, there are no exceptions to that one.
Alright, cool.
I mean, the only quote unquote exception is when you like ignore forces, but there's still a force. You're just ignoring it. But anyway, we got a couple minutes left. What was one out of you guys who took the test? What was the next one you guys want to go over?
Can we honestly just go over all of them except for the ones we've already reviewed?
All right, you know what? If you want to be that way,
We already reviewed that, I think. But
did we do this one?
Nope.
Why don't we just go over the ones that like at least one person got wrong? Because like, there's probably a bunch of questions. That
Alright.
okay, yeah, at least one person got wrong. That's all
Okay,
of them.
so that's not all of them actually.
Oh.
That is not all of them.
Yo, eight, bro.
Okay, so we didn't do these, right? Just to check.
No.
Okay, I have to like kind of zoom out because it's like 3 questions long. What? Why is, bruh?
Bro, Neil, what are you doing? How?
All right. These 3. Good luck. But we've already done another graph question. This uses a very similar concept. So, questions 7, 8, and 9. DM or put it in chat. And we'll try and go over it relatively fast.
I plead the 5th.
Who's talking? Ellie, these are graph questions. They're not hard.
Graph
Just
questions.
try. Just try.
Questions should be like sleep. Because there's no.
Okay,
There's
I
no
would go to sleep.
Graph questions,
Thank
you
you.
just gotta think like, okay, the slope is literally just gonna be y over x.
there are 3 things they can ask you from a graph. They can
The
ask
box
you.
is canceled. The box is canceled, Alan.
There are 3 things they can ask you from a graph. They can ask you about the actual like y value. They can ask you about the area under the graph. They can ask you about the slope. So whatever
Can
you're looking for is
you
gonna be one of
zoom in
those
a
3.
little bit, Nathan?
What?
Can you zoom in a little
I
bit?
mean, it's hard because it's like 3 questions, but I can try.
I don't need to see your name to answer the question, Nathan.
All right. Fair enough. Also, I made these graphs as well. Okay, very proud of that. So I hope that's appreciated as well.
This wasn't the one.
Is
These weren't the ones.
appreciated.
No, these are the ones that I wanted to just rip from the PDF, but you made them again.
Because the ones from the PDF were cringe.
Look, they worked. Okay. You could see them, and you could tell that they were graphs. Maybe.
Mm. I ain't so sure about that. All right. Okay, that's one. That's a different chat there. Let me check. General. All right, thank you for the answer of your mom and your mom.
You're welcome.
Damn, someone's genius.
I think y'all crap on Neil, but maybe he actually like secretly knows. Or he also, he could just be looking at the
No,
PDF
dude,
that has the answers, right?
I hope you don't. I hope
There's
you
a
don't
PDF.
just
Wait,
take
where?
everything said as like jealousy or envy or like hate.
Oh, it's called
Ultimately
big
admire
answers.
the fact that he knows
Well,
how
I'm
to
gonna try to
answer
figure this out and then see.
Okay, well, Neil, just
I
were
don't
were you
know.
using the answer PDF? I'm just curious. Not that I care. I'm just
No.
curious. Okay,
I don't
that's
even know
pretty
there was
impressive.
one.
He's
He
just
learns
that
the
good.
chem
bro.
the
I
day on the
aspire to
test.
be. I don't hate on him, but I aspire to be like him.
Honestly, Neil, you should have taken the test. I want to see what you would have gotten.
Neil, okay, this is how Neil works. Okay, he may
would
not
kill
get the
me.
best.
He would kill me.
He may not get the best
Oh,
results,
but
but he gets the best results for the amount of time that he puts in.
Fair
at
enough.
the
Fair
same
enough.
time, though, he has been doing Khan Academy like specifically on like velocity and acceleration graphs and stuff. So like you just do like a torque problem or like a torque problem next.
No,
and
dynamics.
just see-
We do dynamics.
Well, have him do a simple harmonic motion one, and
I
just
can
wanna-
do anything that doesn't have anything to do with this, with acceleration or kinematics or anything else.
Alright.
I'm screwed. So
All right. So this, I think that's everyone. So we're gonna go over it. So, Ellie said something about the graphs for number 7. So Ellie, would you like to state what you found for number 7?
Cancel.
All right. So we're not talking about Twitter. So can you be more specific?
Bruh.
Hashtag Nathan is over party.
Hashtag
Okay,
Ellie is over party.
No, I'm still going on, bro. I got this right, I think.
You
They-
did.
they-
I would not ask you if you got it wrong. So you got it right.
No, because they canceled. It's like just like we did with the weird triangle ones. If you area under the graph, if you highlight that stuff, they the same, but opposite.
How did you know
Right.
it was area under the graph?
Because it's a graph.
That's not
All
the
right.
right answer.
So
Because
again,
it did
let's
another. Because there was another farthest one. It was another thing I was talking about distance.
all right. Let's think. Go back to what we talked about units. Okay. Remember, what is area under the graph? It's going to be the y-axis times the x-axis. The y-axis is meters per second. The x-axis is seconds. Seconds cancel out. Imagine I actually crossed through that. Imagine I actually crossed through that. And that is wait. That is meters. So that means that the area under a velocity time graph is displacement, which is in meters. So as you can see, in this graph, what is the displacement of object A?
0.
0, exactly. And the displacement of this one is something that isn't 0. So therefore, object B went farther.
He literally just guessed on 9 and got it right. He just picked a random one and got it right.
Oh, my.
This isn't
This is
fair.
the man that learns the chem on the day of the test and gets a higher grade.
Ugh.
well,
That's because he collusions.
Well, I could
Collusion
do a
with them.
collusion, but like Hicks doesn't like
Collusion.
puts Hicks answers or questions are like not on the internet, sadly. But
All
Alright,
I'm gonna
so wait.
say is there is skill to guessing the answers to questions. That is a valid test. That
There
is a
is?
test
Oh.
strategy.
True. Oh, yo, Neil, did you know that the exact thing that happened to us with the collusion thing, where like Higgs got mad at us for like working together
Oh,
on a
yeah.
group project? Yeah, the
Oh
exact
yeah,
thing.
oh yeah.
The exact thing
because we used the same graph on a group project. We had the
No,
same
apparently the
number.
exact same thing happened to them on the first lab,
Yep.
which is really
No. But the funniest part is we were working on the graph in front of him on my laptop, talking about it like we're gonna put it on the same document, and he says nothing. And then he
No,
uses our
he
report
does
back.
say something, Alan. He says, "Wow, that's a cool graph."
and then we turn and he's like, "I want you to never ever do this again." I'm like, "What the hell are you talking about? What?"
Alan scared me last week because
Yeah.
this
get
man
that.
on this specific heat lab, I sent him my document to check it over. He submitted my document.
No.
It's not my fault that they're the same name.
What
All right,
do you mean?
all
You
right.
gotta
Let's finish this. Let's finish this. Okay. So, we're on 8. Sorry, I'm just scrolling my answer key to make sure I don't screw it up. All right. So, which object moves with a constant non-zero acceleration? So, what would a constant non-zero acceleration look like? Or I guess a better way, what part of a velocity time graph is the acceleration? It's obviously not the area under the graph because that's displacement. So, what is the
slope.
The slope. So, what would a constant non-zero acceleration look like?
Linear.
Right. It would have to be like a straight line, like that. So, which of these graphs looks like that?
Nothing.
Correct. So, the correct answer is neither A nor B. Finally, which object is in its initial position at time t equals 2 seconds?
Wait, for 8, wouldn't it wouldn't that just be 0 acceleration? Huh?
So this one has 0 acceleration, and this one has a non-zero changing acceleration.
Oh, okay. Constant on 0. Okay.
Neither of them have constants. They have to be a straight line. So 7 and 9 are very similar. Which one is object in its initial position at time t equals 2 seconds? That is which one? A, and that is exactly the same reason as what we answered 7, because area under the graph is displacement, or a distance from initial position, and this one here cancels out this, so this one has a displacement of 0, which means it's initial position. So 9 is A. Any questions about that? Cool. All right. Well,
Neil picked
it's past
9A because 9 and A sound cool together.
Okay. So anyway, that's it for today. We'll continue next week, and then obviously none the week after because your test is on Monday. So.
Oh wait, what?
I'm pretty sure it's on Monday.
Bro, you good?
It's on the 5th.
It's on
I thought it was
Wednesday.
the third.
It's 2 Wednesdays from now.
Okay, I guess it's on the 5th. Well, we're not gonna do anything.
Close
Well,
enough.
we're not okay. We're not
You
gonna
don't
do.
wanna- you
We're
don't wanna hardcore
not
review?
gonna do any studying Tuesday. If you want to do something fun, like you want to play
Mental
Minecraft as a
preparation.
group or something, we can do that.
I just
But
You
start
wanna know my way of
If you-
answering questions.
yeah, if you want to do something fun as a tutoring group or something like that on the Tuesday, we can do
Yeah,
that.
yeah,
We're not gonna do any tutoring on Tuesday. That's fine.
O'Connor
Edward's
did the
private
same
school.
thing in your freshman year and said, "Don't
We have
study."
pizza
on the day before."
party. Alan, we have pizza party.
I mean, you have
Wait,
to
I
ask
thought you're
mom.
not-
Listen. I think we all should take a book out of Mr. Mills's teaching, and we should all just play Minecraft.
Yo,
Ooh.
physics of Minecraft.
Well, you know
drop
what, let's
anvil
do
on
Literally, I'll email Mr. Mills and say, yo, you want to join our Minecraft?
You got a realm, bro.
Wait, what happened to Mr. Mills?
He died. I sold him for candy.
He went to go for his master's degree.
Same thing.
Oh,
Yeah, same thing.
imagine that he's taking his final two and he just decides to play Minecraft the day before.
Honestly, if we do that, I will email him and I'll say, we're doing a random Minecraft thing with the physics students and tutoring. Feel free to join and give.
Are we
your
gonna do like?
wisdom.
Do we do like a Minecraft like Ender Dragon speedrun or something?
Yeah, and then we could use velocity and projectile motion to calculate how to hit the
Calculate where to hit our bow shots.
Yeah. And then
Transmit
we
data
can decide
at very
yeah.
fast speed.
Yeah.
All right, but anyway, I'm still really impressed by Neil's guessing. Obviously, it is way past the end of this, so you guys can dip.
Dip?
But
Okay, can you explain number 4 now?
yeah. Okay, so we go to number 4. Basically, all right, I'm gonna try and erase it, and it's not gonna work. Watch. Actually, I'm gonna do the fancy erasing. That's not the fancy erasing. How do I? Is it like this? Oh, that's pog. All right, so basically, what is the most important force that's going to be opposing motion when it's going through the pail of hay? What type of force will that be?
Friction.
Friction, right? And friction only depends on the normal force, which is going to be the same for both arrows. They have the same mass, identical arrows. Everything else is the same. So the normal force is going to be the same. We're talking about a difference in energy. So what energy equation relates force to penetration distance, or just distance?
I have no clue, bro.
All right, it is force parallel times distance, or just force times distance, or force FD cosine theta. Any of those. It's the same equation.
I did not know that.
Isn't
All
that
right,
work?
so here's where we go. Well, it's all technically work. Work is just changing energy. But if we go to the formula sheet, it's somewhere on here. It's right here.
Oh yeah, true. I didn't think of using that.
So, then we solve for D. So D is equal to energy over force parallel, and we said force parallel is a constant. And it asks what happens if arrow 1 is twice the kinetic energy as arrow 2. So if we double energy, what happens to distance?
That doubles.
Distance doubles, and that's why it's B.
Let's go. I have Neil level guessing skills.
Nice, good stuff.
Nobody can reach his level. Can't even compare yourself.
I mean, honestly, I wish he'd taken the test because I wanted to see what he would get. But oh well.
Still not too late.
-9.
He'd probably get like a 4.
Nah, he's gonna get a 6.
Nah, I'm gonna get like a 0.
Did you hear my explanation
That's cap.
for the momentum one? I was talking about a shopping cart and how it would hurt more if it was heavier. Yeah, man. Big shopping
Wait.
cart
Can I just see what would Neil do for
Fishbowl, Mike.
Simple harmonic motion one.
No.
Wait, it's simple harmonic.
no.
Okay, I don't even know.
No,
it's a simple
not
harmonic
that one.
function.
The string one. The string one. The last one we did yesterday.
The box one? I
Rainbow.
mean, he's gonna probably get it wrong because it's a hard question.
So
No,
wait,
but he's gonna
okay,
guess it.
I wanna
He's
see
gonna
what
guess
he
it.
does for-
I'm gonna get it
I
right.
He's gonna guess
wanna
it.
see-
There's no. I don't even know. I literally only know kinematics.
This
so.
one is so hard, alright?
It is. It is an extremely hard
What
question.
is that? Okay.
Yeah, solve it.
Oh.
Neil.
Yeah, no, Neil,
Matchless.
Neil. If you
No,
can get this one
don't
right,
even solve it. Just guess it.
I'm
You're
getting
gonna
it
get
wrong,
it.
yeah.
You're gonna guess it somehow.
No,
When an
try
object
to-
of
try
length
to do
W
it.
is suspended
no
from the
way, I
center
don't
of
even
the
know what
mass
to
of the string
do.
as shown above, attention at any point on the
Sounds
string
perfect.
is B.
nope.
I'm crying.
Yeah. Neil, you have a 1/3
wait,
chance.
it's
You have to get it right.
Yeah, oh, it's not B. Okay, watch me B. Okay, let's see. So there's W. So I'm gonna cut out A. It's either C or D. And there's one box. So I'm gonna go with D. I don't know.
Okay, however, here's the thing. He had the advantage of not knowing it was B because Alan said it's not B. So like, I feel like if Alan didn't say it wasn't B, he wouldn't know that.
Go down another problem.
This is
Aren't B and C the same?
No, I know it's not happening twice. I
No,
already
B and C
know.
are the same because the C is divided by 2
Oh wait, he already
cosine.
learned it. He's learning this right now.
Okay, you know, also, hey, I was talking about I'm super triggered how this image was low quality. It was a mistake on my part. I should
What?
note. Like,
Gaussian blur?
and now that's the correct answer is D. But anyway,
Yeah.
whatever.
Wait. Do some simple. Throw some simple harmonic motion on this.
No,
one.
not the graph, please.
Give him that one. Give him. Oh wait.
No, give
wait,
it. Yeah,
wait.
do this one. Do
No!
this
No!
one.
Give him this one. Give him this one. Give him this
On
one.
45?
Oh, Neil, you're screwed.
45? Which guy with the total mechanical energy of the block?
yeah,
What's a
by the-
block spring system?
Okay, no. I want to point out
Uh,
this text up here. Yeah, this is completely wrong. Ignore this text. That was a typo. But
Three objects.
just read the question.
The
You have a
This
2
graph can
centimeter
represent the
typo.
total mechanical energy of the block spring system as a function of X.
D.
I don't know.
Which one did you say? Which one did you say?
Wait.
Wait,
No, no, we
Wait,
need
you
we
said
need we
D,
need, we
right?
need to let Neil guess too.
Neil, come on.
What? Okay. So triangle, oval, half oval, and actually
Which
other
one's
way
the
half
oval and which one's the half oval?
That's a parabola.
A to half, and box. Okay. So the total
I think
mechanical
46 is
block
A.
spring- So if I'm assuming since it's a block
minute.
spring system that the graph would look like a block, but I'm going with block.
So it's a D.
It's D?
Yeah.
The hell?
Block.
How? How do
Oh
you?
my god, you're right!
For
Yo!
45.
All right, 46,
Okay,
46.
okay,
Which
okay.
one's 46? 46. Come on, 46.
I knew once I saw, I was like, he's gonna pick the one that looks like a block, and he's gonna get it right.
I think it's A, because B and C kind of look the same.
Okay.
Wait, Ellie, stop interfering. We need to have a valid test.
Bruh, I'm trying to pass!
We're trying to make Neil fail.
I would assume it's a block, but I doubt they would make two blocks twice.
It's not the same energy, bruh.
I'm actually, to be fair, I'm actually very happy that everyone who took this test got 46 right. That's pretty good. Actually, got both 45 and 46 right.
The
So that was
kinetic
good.
energy.
Yeah, thank you,
Wait,
Michael.
is the
Uh,
spring
Neil?
going in or out?
Well, the box
It's
stops,
oscillating.
right?
Neil, if you think about it,
Oh.
if you think about it
Neil,
correctly
wait,
and use the process of elimination, then you have
Okay.
basically have a 50% chance.
Wait, shh. Neil?
Well, the
What is it?
box stops at some point. I think. Does it? Maybe. So, it can't be B. It could be okay. Accelerates first. So it can't be A, I don't think. And D goes straight up, so that one makes sense. So I'm gonna go with the half oval that is where the opening is facing the x-axis, so C.
That's a parabola.
Okay, there's no way.
Why? How?
I didn't know it was going that way. I thought it was going backwards. Now I'm back.
Here, 47.
Okay, I got this. P and Q have the same momentum. If P has
Okay, Neil.
more mass than P, what the hell?
If Q has more kinetic energy, then
Then
if
P,
more.
if it-
Well, I'm gonna go with the same logic as 4 and
I
C
got
and assume that it has more speed. I don't know.
Jesus Christ.
That's cap. There's no way. Okay.
Is it?
If
Is
as long as he meant C, yeah, 47C.
What?
Okay. I thought it was the same logic as
Alright,
4.
screw it. He's getting Neil. I recommend you don't study anymore and just do whatever you're doing right now.
It seems like Neil has
No,
like a
this is all-
subconscious understanding.
No,
because
he's just good at eliminating
He
options.
studied all of velocity and time and speed graphs. All right, you need to give him something that doesn't have anything to do with that, like at
All right,
all.
but like, here's the thing. Actually, I can show you. This is us planning for the test right here.
Like Cam.
The like when we were making the exam. I'll start the video, Camille. So don't ask.
Mining calculator? Yo?
So you can see kinematics is 10 to 16% of the test. So like, if you know kinematics,
Give him torque. Give him some torque, bro. Give him circular motion and torque. All right.
Give him like
He-
angular momentum or something.
all right,
yeah,
here.
give
I'll
him
make,
some
hold on,
ground.
I'm
You
gonna
want
make
to try to make
calculator.
him do an F or Q on the fly?
I don't even know.
Give him the farthest
I don't know any of the.
Alright,
I don't
so,
know any-
question-
I don't know any
Alright,
English
alright.
stuff.
Everyone, shut up. Question 23.
Bruh.
Question
That's
20.
not very nice. I'm gonna take away your cast hours, bro.
All right, whatever. You do
I'm
that.
reporting you to
Question-
the ID.
Question 23 is this.
Okay, yeah. All right, here we go.
Yes.
No graphs. Try
No
this one.
graphs, yo. You have a disc that is spun from rest by a motor until it reaches its set top angular velocity.
Okay, I
It
have to go
passes
after this one. This is my last one.
to determine the
Okay,
torque. Ew.
this cause what is this? I didn't know they had motors in physics. Okay.
Bro.
No. Be happy you didn't have be happy you don't have DC circuits because you didn't figure out how a motor works for your test. That's fun.
Bruh.
I
can't
mean,
imagine
listen,
doing
I'm kind of
electricity,
biased.
though.
Electricity
I
was
have
my
no
favorite.
idea.
section.
Electricity was cool, but
Wait,
I have
what?
no idea. I can go eeny, meeny, miny.
All right, well, tell me what you say.
Uh,
What you say?
okay. Let's a group.
This one's easy.
What do you mean this one's easy?
Dude, he doesn't know anything that's not linear velocity. All right, that's how that carries him on all the other.
Pick a number.
That's-
Pick a
okay.
number. Pick a number between. Okay, someone pick a number between 1 and 10.
No,
3.
no one pick a number between 1 and 10.
3.
Okay, 3, 1, 2. Okay, so I'm just gonna like just count randomly. Okay, 1, 5, 8, 3, 7, 5, 1, 8.
what is he doing?
I don't know.
What is his strategy?
You know what? I'm just gonna go with
Audacity, yo.
B for
DJ
bad.
Nathan.
I don't know.
Bah!
Wait, what did he just say?
B
Uh,
for bat.
That's cringe. Alright, but also on a that's correct. But also on a serious note,
I got it right!
on a
I
serious
just-
note, on a serious note, do you guys see after taking this test what we were talking about? How the test isn't really like super math heavy.
Yes.
Yes. But how?
Why the hell graph heavy?
Can someone explain to me how Neil has not missed a single question?
Well, I mean, there were
I
answer
think,
keys.
okay, here's the thing. I'm assuming that I'm just gonna take the assumption that like I'm the luckiest person ever, and that this is never gonna happen again. So.
Well, you better hope you didn't just use all your luck before the test, because
Bro, no, he Christmas treed a test last
I mean,
year
this
in
one's
an AP
actually
World
easy, but
and got an 80.
there's a
What?
difference between Christmas
Yeah,
treeing and
I don't
guessing
know
on
if
every
that's-
question. There are tests that I guessed on every question for in like history and still managed to score well.
No. He Christmas treated and got an 80.
Anyways,
Christmas
Yeah.
I have to
treed
go
and
to
got-
Like
audio.
completely random.
tried-
Yes, because
tried
he was
and got a
working on his
23.
packet in the middle of it. He did it in like 5 minutes.
Okay, that's
Well,
because
to be
he
fair, half
Oh,
of
yeah,
it
right
was
before
mine.
I go, I decided to make a pattern. I just choose random answers, and yeah, I've made a
No,
cool.
no. Neil,
So.
Neil, you do better on the ones you have some semblance of.
Alan, if you haven't already stopped
So
recording, you
Oh.
should
study
probably do
everything.
that, and you should probably upload the video.
Yeah, I
Anyways.
did that.
Did you upload the video?
All right, well, I'm
Uh,
gonna.
I don't understand how that is
no.
even possible.